Today's lesson is 6.2, Add and Subtract Rational Expressions. When you are going to add or subtract fractions, the denominators must be the same. The same is true for adding and subtracting rational expressions. The denominators must have the same expression before you can go ahead and add or subtract the numerators. So let's go ahead and take a look at our example number 1. The first thing you want to do is you want to focus on the denominator, which is the bottom of each one of our rational expressions. I'm going to highlight them both and make sure that they are exactly the same. Since they are both x minus 6, I can go ahead and I can make one denominator of x minus 6, and I can take my two numerators, x and 7, and I can add them together. Okay, now I would consider this a factor and I would consider that a factor. Since they are not the same, 7 and 6 are different, plus and minus is different, nothing is going to cancel, and this is going to be our answer. Let's go ahead and take a look at a subtraction problem. So the same rules apply. You just need to make sure that you first look at the denominators and make sure that they are exactly the same. They are. So now what I can do is I can go ahead and I can subtract the numerators. Okay. Be careful with subtraction because you have to go ahead and distribute to the second numerator. So x squared minus 4 is going to stay, but I have to take my subtraction and I have to remember to distribute it to my second numerator. Okay, so what's going to actually happen here, once I do my distributing, is I'm going to get minus 2x, but when I distribute the negative here, I'm going to end up with plus 1. So let's go ahead and do that next. I'm going to have x squared minus 4 minus 2x plus 1. Okay, be very, very careful. Now what I can do in the numerator is I can go ahead and combine like terms. I can go ahead and combine like terms. And I'm going to do that with, let's use the green. Negative 4 and positive 1 would be my like terms. So I'm going to go ahead and I'm going to add negative 4 plus 1, and I'm going to move over here because I need a little bit more space, x squared minus 2x, because I'm putting it in my standard form, minus 3. Now, the last thing I have to do is I have to see if I can factor the numerator. The denominator is already a factor. I could just go ahead and put it in parentheses because x plus a number or x minus a number can be considered a factor. And so they can stay together in parentheses. But in the numerator, I have to go ahead and I have to factor. So I'm going to use my little trick, which says x squared is x times x, and I'm going to place them one on top of each other. Then I'm going to look at my C term, which is 3. 3 is 1 times 3. It is negative, so that means one of these is negative and the other one is positive. But I'm going to let the B term do the deciding for me. I'm going to crisscross multiply, so 1 times x is 1x, and x times 3 is 3x. I'm going to add these two together, and I want to see if I can get that b term, which is negative 2x. I think I can. I think I can make 1 and 3 become negative if I put negative 3 in my calculator and positive 1. So 1 plus negative 3, or 1 minus 3, gives me negative 2x. That means my first factor is plus, and my second factor is minus. All right, here we go. I'm going to move over here because I need one more step. I have now the factors x plus 1 and x minus 3 in the numerator, and in the denominator, I have x minus 3. I can see that I have two x minus 3s, one in the top, one in the bottom, one in the numerator, one in the denominator. So they will completely cancel each other out because they are exactly the same. And my final answer is x plus 1. I have nothing left in the denominator. All right, let's give one more a try, and then I'm going to ask you to pause the video and try one on your own. All right, let's take a look at this one. We're going back to adding. And remember, take a look. 2x squared plus 14x plus 20, 2x squared plus 14x plus 20. They are exactly the same, so we're going to go ahead and we are going to add together the numerators. So let's go ahead and start right over here. I might need a lot of space. My denominator is just going to be one of those two highlighted polynomials. Okay, I don't have to do anything to it. I'm going to take my x plus 7 from the numerator of my first rational expression plus the numerator for my second rational expression. I don't have to worry with a positive about distributing. I can just go ahead and leave it just like this. I'm going to go ahead and combine my like terms. So just like before, the 7, which is positive, goes with the 1, which is also positive. And I know they don't really match, but let's use the orange. I have x plus x. Okay, just so that you can see what goes together in the numerator. So x plus x would give me 2x, and 7 plus 1 would give me 8. Now, 2 and 8 are both even, so I can go ahead and factor out at least a 2, if not more. I could maybe take 2 2's or 3 2's, it just depends. In the denominator, I see that I have a 2x, I have a 14, I have a 2x squared, I have a 14x, and I have a 20. 2, 14, and 20 are also all even, so I can take a 2 away from them as well. So I'm going to go ahead and grab my lighter shade of gray, and I'm just going to come up here and say, well, 2x is 1 times 2 times x, and 8 is 2 times 4. And down here, I can think of it as 1 times 2 times x plus, well, there's a plus in between at the top too, 2 times 7 times x plus 2 times 5, right? Because it's 2 times 10, right? So 2 times 2 times 5. All right, so what I'm looking for is a GCF, the greatest common factor, just like we talked about in lesson 6.1. So let's look at the numerator. My greatest common factor that the two have in the numerator is the 2. They only have the 1. Now the 4 is actually 2 times 2, and I could have done that, but I knew I didn't need it. So I'm going to put the blue 2 that they have in common in the numerator first. Then I'm going to put a parenthesis. Then I'm going to look right here, what's left in the gray. Well, the 1 and the x. Remember, you can always ignore a 1 and you can put the x. Then I'm going to put the plus sign, because that's what's there. And then I'm going to look right here, what's left when I take away the 2, because the blue 2's already out here. These 2's are the same. I'm just going to go ahead and put the 4. All right. In the denominator, I can see that they have a 2 and a 2 and a 2. Now, notice that there's an x and there's an x, but notice there's no x. So can I take an x? No, I can't. They all three would have to give me an x for me to be able to take an x as a GCF, and so that means I can't. I can go ahead and I can simply factor out the 2 in blue that they all have. What's left here is the 1 and the 2 x's. So remember, the 1 we can ignore. It's x times x, which I know to write as x squared, plus, because that's what's right here, right? And then what's left here? 7x plus, what's left here? 2 times 5, which remember we talked about this, that's 10. So let's go ahead and put plus 10. All right, just like in the last one, I have to go ahead and I have to see, can I factor this polynomial right here? Because if I can, if this is factorable and has a factor of 4, then I can go ahead and I can factor. If not, it's okay to leave it just like this. So I'm going to go ahead and I'm going to look right over here to the side. You know what? Let's do it like this. X squared plus 7x plus 10. Because if it doesn't have to be factored, I actually don't have to factor it. So I'm going to look at x. X squared would be x times x. And then I'm going to look at 10. 10 is going to be 1 times 10 or 2 times 5. Because my b term right here is 7x, I'm going to pick this one. I'm going to pick 2 times 5. That would mean that my two factors inside my parentheses are going to be 2 and 5. And I'm going to go ahead and look right over here. The factor in the numerator that I have is 4. 2 and 5 does not match 4. 1 and 10 do not match 4. So there's really no need for me to factor this. Just for practice purposes, though, it would factor into 2 and 5. It would factor into 2 and 5. And 2x from this multiplication plus 5x from that multiplication is going to give you the 7x that you need to factor. Everything is positive, so you would have x squared, you would have x plus 2 times x plus 5, okay? But going back, there's really no need to do that because it's not going to cancel out on the top. And so there's really no need for you to actually factor the denominator. I just did that for practice. Okay, but what does cancel are the 2's. There's a 2 in the numerator, there's a 2 in the denominator, so they will cancel one another. And so my final answer, you could write it one of two ways. You could write it just like this, x plus 4 times x squared plus 7x plus 10. This is a perfectly acceptable way to write your answer. You could even take away the parentheses. Oops. Oh, I really messed that up, sorry. You could just leave it without the parentheses on the top as well. Another way that you could write it, and I'm going to put this in a lighter color and put or, because I'm not really sure what Alex is going to have you do. You could leave the x plus 4 in the top, and then you could write the factored form in the bottom. They are both technically correct. There's just no need to actually factor the bottom because it does not, neither one of these two matches the term on the top. Neither one of these matches the term on the top, so there's no reason to actually factor. All right, let's take a look at our last question. And if you were in class today, this is the one that I asked you to try on the Padlet. So what I'd like you to do right now is to pause the video and see if maybe you can figure it out. Now, if you were in class today, I did give you 4 multiple choice answers to choose from. So I'm going to go ahead and while you're working, I'm going to put our multiple choice answers on the screen. All right, hopefully you saw an answer that you got added in the answer choices. Let's go ahead and take a look. So right away from the beginning, I know I can go ahead and I can subtract, just like to remind myself that I am subtracting, because my denominators are the same. So don't forget that one of the first things you need to do when you are subtracting that is different from adding is that you need to make sure that you are distributing that subtraction to the second numerator. So you need to make sure that you do write it like this so that you can come in and distribute this. This is going to become a negative x, and this is going to become a negative 7. This is going to become a negative x, and it's going to become a negative 7. All right, once you've done that, then you want to look for any like terms in the numerator that you can combine. I do see some like terms. Normally when I have 3, 4, or 5 terms, it normally means that 2 of them belong together and are alike. And our like terms here are going to be the 3 and the minus 7. So I just want to go ahead and pop in my calculator 3 minus 7, or pop it in my brain. 3 minus 7 is negative 4. And now it would be more proper to see the minus x first and then the minus 4. Okay. Now, the last thing that you should check is you should check to see if x squared minus 9 is factorable. It is. X squared minus 9 is the difference of perfect squares. X squared is x times x, and 9 is 3 times 3. A perfect square, remember, is a number that is multiplied by itself. So 9 is a perfect square, 3 times 3. 3 plus 3 is 6, and I don't see a 6x there, but 3 minus 3 is 0, and I do see a 0x. I do see that missing. So if I were to factor this, I would end up with 3 and 3, and I would end up with a positive 3, and I would end up with a negative 3, because remember, you want to get that 0. I don't know why my pen's not working. There we go. But I need 0x, right? It needs to be 0x because there's 0x right here. So one of them is positive and one of them is negative. So here are your two factors in the denominator. Notice once again, just like before in the last example that we talked about, my two factors in the denominator are going to be 3. My factor in the numerator is 4. 3 and 4 are different, and so they will not cancel out. So my answer is this one right here, which happens to be answer choice D.